My dear students, I hope you have written this ESE Prelims technical exam very well. As a team from ACE Engineering Academy and ACE Online from Electrical Department, we here are going to start the complete detailed video solutions for this technical paper. Okay, here I am presenting my team with most experienced faculty from ACE Engineering Academy and ACE Online. Sorry for the delay, slightly 10 to 12 minutes as there was a technical glitch in broadcasting. Okay, we will start the session. Thank you. Yes, here I am presenting the marks division very accurately. As you know, this exam paper is released and students did share with us, and with the accurate data I am presenting this marks division. Myself B.S. Krishnavarma, faculty in ACE Engineering Academy since 2009 and now ACE Online also. Yes, this is ESE Technical Preliminary Paper 1. Yeah, paper 2 today, but overall technical electrical question paper analysis. Now this is very important slide that you go through now. As you know, all the subjects, okay, including communication, technical subjects, core subjects. Now engineering mathematics came for 13 questions, electrical materials 13, circuits and fields 12, electrical electronic measurements 14, computer fundamentals 11, basic electronic engineering where EDC and analog combined to 16, digital electronics and microprocessors 4 plus 2, 6, systems and signal processing 13, control system 12, electrical machines 12, power systems 12, power electronics 12 and communication 4. This time I say it is one of the most accurately divided paper. Okay, so the balance was too good. All the subjects are given importance, and you see the core subjects 12, 12, 12 evenly divided. Okay, so now we will start with the detailed solution. We will start first with power system. Okay.
Hello everybody, welcome back. So now we'll start with power systems. The first question in power systems, so it is related to power system stability analysis, students. See here, consider the following statements with respect to the change in torque angle whenever disturbance occurs. It is given that there is no change in torque angle when speed of rotor is synchronous speed. Yes, whenever synchronous speed omega is exactly equivalent to omega s. Under that condition, d delta by dt, which is defined as omega minus omega s. When omega is equivalent to omega s, d delta by dt is equivalent to 0, we can say the rotor angle is constant. So that statement 1 is correct. Coming to the second one, the angle decreases in case of motor. They are saying that delta decreases in case of motor when the mechanical load is more than that of the electrical power input. For a motor, we can say d delta by dt is equivalent to omega s minus omega, and d omega by dt is nothing but Pe minus Ps. See here students, whenever Ps is more, d omega by dt will be less, so that we can say omega will be reduced. Whenever omega is reduced, the difference between omega and omega s and omega will be more, therefore d delta by dt will be increased. Why? Because d delta by dt is now positive. So when d delta by dt is positive, we can say delta increases, but it is given that delta decreases, so that second statement will be wrong. And third statement, it is given that the angle increases if the speed is more than that of the synchronous speed. The reverse statement will be given, right? That will be the correct statement. So that 1 and 3 are correct. So that option D will be the correct statement, students. Option D will be the correct statement. right? And the next statement, the next question you can see here, which of the following is not a feature of ideal control system for an HVDC converter? So in case of HVDC system, control should be such that it should require less reactive power. Yes, it always needs less reactive power, students. HVDC system always needs less reactive power, right? And the DC current is constant, ripple free. We don't find a DC current which is constant in HVDC system. Every DC system is consisting of ripple content. So that second statement is the wrong statement. You no need to see the remaining statements also. Got it, right? So that what is the correct answer? The correct answer is B, right? They are asking which is not correct. So that option B is the correct answer, right, students? Next one, consider the following statements regarding static synchronous compensator, STATCOM. It is insensitive to transmission system harmonics. We cannot find a HVDC system or STATCOM system without sensitivity to harmonics. So that it's a wrong statement. And it has difficulty in operating with a very weak AC system. No, it does not have any difficulty. It is always having a very proper operation with any weak system also. And it can be used for small amount of energy storage. Yes, it can be used for any small amount of energy storage. This is wrong statement. This will be the correct statement. We can go with only statement 3. Statement 3 is the correct one. And coming to the next question, students, consider the following advantages of hydrogen cooling of alternator in steam power generation. So in hydrogen cooling, less noise will be there and ventilation losses will be reduced. It is given that increased, and the heat transfer is more, right? So that 1 and 3 statements are correct. So that option D will be the correct statement, right? And coming to the next question, students, so it is somewhat a question given based on the types of the conductors. It is given that Beer-Smith conductor, moose conductor, zebra conductor, snowbird conductor. So I have shown in the classroom some of the conductors like dog conductor, panther conductor, moose conductor, zebra conductor, like that, right? So it is given that quad conductor means there will be number of 4 strands will be there. Twin conductor means 2 conductors will be there, right? Triple conductors means 3 conductors will be there, right? So in this one, the Beer-Smith conductor is having the highest surge impedance loading. So that as we are having 4 conductors, as the number of conductors are more, its surge impedance loading will be very high. So that here we are having quad conductor, here we are having quad conductor. For these two, we have to give the highest surge impedance loading. So that for Beer-Smith, we are giving 691 P3. We are going with P3. So that directly you can go for option A. And second one is zebra conductor, quad. It is also 4. The next one, 647, you can give R1, right? We can give R1. Got it, right? Remaining automatically you can match. Right, students? The next question we can see here. If D is the distance between the conductors and E is the Euler's number, then the maximum critical disruptive voltage occurs when the radius of the conductor is. Just see here, students, the critical disruptive voltage Vd is equivalent to mgr ln of d by r. Mgr ln of d by r. Whenever this value is becoming 1, then maximum critical disruptive voltage we are going to get. Here you have to match R with D. When R is equivalent to d by E, then what happens? It will be mgr ln of d by E. It will be dd will be cancelled, ln of E will become 1, so that it will become mgr. So where you are going to get d by E, we are going to get the maximum value. So that option C is the correct answer, students. And coming to the next question here. Yeah. See, very simple question. Match the list here. First of all, the element overhead transmission line, where you are going to get the highest faults. We know we have discussed many times in the class, overhead transmission line is a open system. Faults because of snakes, small because of monkeys, small because of trees. There are a lot of reasons we will get the faults in the transmission lines. So that highest probability will be transmission lines. Match this one, right? So that P2 will be there. 3 options are there. And next one is the transformers. The transformers are also in open area. The next highest one give to the next one. So R1, P2, R1. So that we can go with option C. Least probability of fault is generators. Got it, right? Next one. For a 735 kilovolts line with a fault current of 4 kiloamperes, what is the arc resistance? the arc resistance formula R arc is nothing but 28710 into length of the arc divided by current whole power 4.5. Substitute the value of current, it is given 4 kiloamperes. It is 28710 into line length, we can assume it as 1 meter, not line length, arc length, divided by 4 kilo, 4 into 10 power 3 power 4.5. If you calculate this one, approximately we are getting it as 0.183 ohms. That the approximate answer will be 0.183 ohms. Right. The next question, again it is beyond the syllabus, the static relays. Right. In static relays, frequent operations cause deterioration? No. So there is no problem of deterioration in the static relays. And in static relays, there is a quick resetting and absent of overshoot. Yes, that's the correct statement. Static relays are sensitive to voltage transients. So that 2 and 3 are correct. 2 and 3 direct statements only. Right. So the next question, what is the maximum value of restriking voltage across the contacts of circuit breaker? The maximum voltage across the circuit breaker contacts is the maximum value of restriking voltage. So what is the maximum value of restriking voltage? Restriking voltage, which is nothing but 2 times of ARV, which is nothing but 2 times of VM. So it is 2 times of VM means it is root 2 times of V phase value. It is 2 times of root 2 into V phase is nothing but V line divided by root 3. It is 2 into root 2 into line voltage is given 132 kilovolts divided by root 3. That is the value. If you calculate this one, you are going to get it as 215.56 kilovolts. 215.56 kilovolts. Right. And we'll see the next question here. So very simple question. Many times we have discussed about the radial distribution system. The distributor far away from the substation is heavily loaded. No, we are getting the last consumer is getting the least voltage. If he is having very high load, the voltage will be very less. Right. So the last consumer should never get the highest loading. Next one, severe voltage variation to the consumers nearest to the substation is due to load variations. So at the sending end, we don't have voltage variations. At the receiving end only, we are having the highest voltage variations. This is also wrong statement. The consumers are dependent on single feeder. Radial distribution system, it's a single feeder, and a single distributor and a fault on either of them causes interruption of supply. Yes. So as we are having single radial distribution system, fault at any one location will disturb the overall loads. So that we can go with only statement 3. Statement 3. Right. And very basic question, students, about the classification of the buses. Bus type is given and quantities to be obtained is given. For generator bus, it is a PV bus. Which are unknown? The unknown quantities. P is known, so that Q is unknown, V is known, delta is unknown. So that Q and delta. For generator bus, reactive power and delta, P2. We are having 2 options. Load bus, for load bus which quantities are known? It is called as PQ bus. Which are unknown here? V and delta. So that for load bus, V and delta are unknown. So that Q3, P2, Q3, option A will be the answer, right? P2, Q3 and remaining will be R1. Right, students, these are the questions we are having from the power system. The next subject will be the networks. Right, students?
Yes, dear students, now let us go with the solutions of electric circuits. See, in a ESE, how quick and simple you do, that will be very interesting. But in my circuits, there are some problems where slightly derivative type came. However, detailed solution we will be uploading to the website and you can download. Here I will be teaching in a very compact way, but overall paper was very easy as far as circuits is concerned, but here and there slight derivations came. Now my subject came for total 13 marks or 13 bits, I say, not 13 marks. Now in this, now for the network shown below, what are the Norton currents and Thevenin's voltage? Now Norton current is short circuit current and Thevenin's voltage is open circuit voltage. Though he gave such a big, it's simple application of Ohm's law and current division. Now what about Norton current? Now if it is Norton current, this is the short circuit current I want. So what I will do, first I will find the total impedance in, total impedance is total voltage by total impedance, and then total current and current division rule. So first I will do this Norton current is by current division rule, that is total voltage by, okay, total voltage by total impedance in, that is 10 plus these two in parallel, this into this, that is nothing but minus J10 into 3 plus J4 by this plus this if you add, okay, because they are in parallel, 3 minus J6. Now this is total current, right? Into current division rule is the branch current, not current division rule. Now this current is a Norton current. Now you got total current from Ohm's law. So this current is total current. Opposite. What is opposite? Yes, 3 plus J4 by sum. If you add all these 3 plus J4 minus J10 is 3 minus J6. This is Norton current. Then what about Thevenin's voltage is the open circuit voltage. Now listen, very interesting. Thevenin's voltage is open circuit voltage. But that voltage, because it is open, there is no voltage here. Total voltage appear here only. So it is total voltage by total impedance. Total current itself is this. Now that is nothing but Thevenin's voltage is the voltage here. That is nothing but current into impedance. What is the current? Total voltage by total impedance. This time these three are in series. That is 13, okay, plus J4 into yes, that current into impedance, okay, 3 plus J4. Chalo, if you do this, yes, if you do this, overall you will get an answer which is option D, okay, which is option D. You go through this, okay, you will get option D, okay, you will get this option D here. Now what are Z parameters for the network given? Now he gave a simple network, but there is a dependent source. Now however, you know, in Z parameters, input voltage, input V1 V2 are dependent, that is Z11 I1 plus Z12 I2, and this is Z21 I1 plus Z22 I2. Now however, to find Z11 and Z21, the condition is what? I2 is 0. Now interestingly, if you make I2 0, see here, there is no voltage here, and this itself will become I1. So if you write the first KVL, V1 is 6 I1, so Z11 is 6 ohms. Interestingly, because I2 is 0, there is no voltage across this pass film, but this dependent source still works because I1 exists. Now if you write a KVL here directly, V2 itself is equal to 7 I1 plus 3 I1, 10 I1. So automatically Z21 is 10 ohms. Okay, but interesting is step 2. When you go to step 2, however, to find Z22 and Z12, I1 should be 0. The moment you make I1 0, dependent source get zeros are shorted. That is very interesting. Okay, now this is going to be the case when you make I1 0. Because you are making I1 0, dependent voltage source becoming 0 can be replaced by short circuit. Okay, however, this is 3 and 2. This is V1, I1 is 0. However, this is V2 and I2 exist. Okay, this is not there. So automatically, if you write a KVL, V2 is 5 I2, Z22 is 5 ohms, and then automatically Ohm's law, V1 is 3 I2, Z12 is 3 ohms. So if you see all this, okay, yes, if you see this very carefully from the given data and the options, yes, option A, okay, option A is matching here. Okay, so remember, this is option A. Simple problem, but it takes some time, right? Chalo. Then now there is another problem on two-port network. See this question, the simplified model of BJT, okay, the simplified model of a B, one of the equivalent circuit of BJT transistor for small signals is shown, and is asking us to find the H parameters. Now very interesting, see, this is like one common terminal, okay, now this is like a short circuit ideal wire, and this is there. Now directly, you know, in case of H parameters, input voltage, output current are dependent, H11 I1 plus H12 V2. This, however, H21 I1 plus H22 V2. Now in that one relation we can directly know, see, I2 is beta I1. See, from this very interesting, though these are there, I2 itself is beta I1. From that directly, what is H21? H21 is I2 by I1, I2 by I1. Here I2 by I1 is nothing but beta. So that is the only option. Remaining all short circuits, you see answer won't come. So the clear way, though the system equation exists, observing that I2 is beta I1 itself will give the only option where parameter exists. Remaining all 0 because these are short circuit here. So yes, only thing is H21 exists, remaining all 0. H21 exists, remaining all 0. So option is C. Option is C. Okay. Then now which one of the following statements are not correct? Please understand these are not correct. Okay. Now when assumed current sources both enter or both leave in a pair of coupled coils, the dotted terminals, the M is taken as positive with respect to L. Yes or no? Like I told, in mutually coupled coils, like current is going from left right, both entering or both leaving, M is taken as positive with respect to L. Correct. Second statement. Okay. When one current enters the dotted terminal while other terminals leave, the sign is taken opposite. Suppose the same thing if I write this way, this is M, one entering, one leaving, or you take like the one entering, one leaving is opposite. So M is taken as negative with respect to L. That is also correct statement. What about the third statement? The term close coupling is used to describe the case where most of the flux linkages coil. Good. Close coupling or perfectly coupled. Okay. Either by way of magnetic core to contain the flux or by interleaving the turns of the coils directly over one another. In transformer we do na, primary secondary on we interleave. Coils placed side by side without core are loosely coupled and have corresponding high value. See, until here the statement was good, but here this is a controversial statement. See here, coils placed side by side without core and are loosely coupled have high value of K is meaningless. Tightly coupled or perfectly coupled, K is high, but coils which are side by side and not perfectly coupled, K is low. But he said that coils placed side by side without which are closely coupled are high value K. So this is a wrong statement. Overall, this is a wrong statement. Then if all the flux lines of coil without leakage flux, then K is 1, perfectly coupled. On the other extreme, the coil axis may be oriented such that no flux from first coil links the other is K0. This is also correct. So, but here this statement was wrong. So, option C is only wrong statement. Remaining all simple, direct. It is a theory. Consider the following statement. Now, here also regarding the factors affecting the capacitance. Now, you see C is epsilon naught, epsilon R A by D. But at the same time, we know Q equal to CV. If you apply, okay, C, that is C is Q by V. Q by V is nothing but epsilon naught A by D. So let us now take these two formulas. Now see here, first statement. The area of plates is directly proportional to charge. The larger the plate area, the more charges without saturation. Yes. So charge and area proportional. So first statement is correct. The longer the distance between the two plates, the stronger will be electric field. Okay. And that will increase the ability to store. Therefore, the distance between the two plates is directly proportional to capacitance. No. See, C is inversely proportional to distance. He is saying one way distance is increased but capacitance also increased. No. Second statement is wrong because distance and C are inversely proportional. Different insulating materials will have different impacts on the capacitance. The dielectric constant is proportional to capacitance because here dielectric constant is nothing but relative permittivity. As relative permittivity is directly proportional. So 3 is also correct statement. So now the question is, which of the following statements are correct? Which of the following statements are correct? Now clearly 1 and 3 are correct. Okay, 1 and 3 are correct. Okay, if you see 1 and 3 are correct. Now look at this question now. Yes, which of the following are or is not discharging equation? Now he is talking discharging. Discharging means off process. Okay, capacitor is discharging for an RC circuit. So if you take a simple source free first order RC circuit where state variable is capacitor voltage, you know this. Okay, see, and this is the voltage expression where of course this V of 0 is V naught. Then you know the expression for state variable, this V of t is V naught e power minus t by tau. Tau is RC. So this is the voltage across capacitor which is exponentially decaying off process because he mentioned this term called discharging. Okay, so yes, this is the equation we know, that is for capacitor. So capacitor voltage is correct. Then resistor voltage. Now both are parallel. How can resistor voltage will be different? When both are parallel, VR equal to VC. This is also same statement. V naught e power minus t by RC. So this is wrong. Then discharging current. Now because he mentioned discharging, however you know, see, while charging we take this expression, while discharging if you do, I is C dV by dt. Okay, if you do, you will get minus here, but nothing is controversial. If you take, that is minus V naught by R e power minus t by tau. But because he mentioned the term discharging current, yes, capacitor is now discharging, it is acting like source. So this minus will not affect anything in this case. So this is also correct. So 1 and 3 are correct. Okay, 1 and 3 are correct. Okay, 1 and 3 are correct. Okay, next. match the following list regarding the time constant. So yes, he is asking when discharge, again here also you please understand, you can synchronize this bit with the next bit, because here also he mentioned match the time constant when capacitor is discharging. You know this expression, again this V of t is V naught e power minus t by tau. So at different time constant. Now V at t equal to 0 is complete V naught, that is a full value. V at t equal to tau, that is e power minus 1 V naught, 0.367 V naught. Then similarly V at t equal to 2 tau, that is e power minus 2 V naught. This I gave in my notes, do you remember? 0.135 V naught, 13%. V at t equal to 3 tau, e power minus 3, 0.0049 or almost 5%. V at t equal to 4 tau, very important, 4 tau, do you remember this? 0.018, almost less than 2% of the error. And V at t equal to 5 tau, 0.006. Now if you see here, you see now at first time constant it is 36.7%. okay, yes, 36.7% of E. okay, first is P is going to 2. Then second time constant you see 13%, second time constant 13%. okay, then third time constant 5%, third time constant is almost 5%, fourth time constant 1.87%, and 5 time constant is almost, yes, 0.067%. So if you see, yes, if you see this, yes, you go accurately, the option is D. Option is D. If you see, yes, option is D. okay, so that means e power minus 1, e power minus 2, I made you write in my notes, do you remember? It is there. Yes, now with what is the power supplied by each element? Power supplied is asking power supplied, so that means source. So here very simple, if it is a source, power supplied is positive. If it is a source, yes, power supplied is positive, but if it is a sink, power supplied is negative. That is the meaning. Chalo, now if you see here, this 20 volts 5 is leaving, so this is a source or not? Yes, for 20 volts 5 is leaving, this is a source, so power supplied is plus 100 watt. Now your current is entering positive, so this is sink, power supplied is negative, minus 60 watt, 12 5s. Here again if you see, current is entering positive, sink, power supplied is negative, minus 48 watt. But here again, here see 8, and this is 0.2i, 0.2 into 5, this is 1 ampere, but this is 8 volts positive, this is again source, because current is leaving positive, power supplied is plus 8 watt. okay, so simply P1 is plus 100, okay, P1 is plus 100, so these two cannot be the answer. Overall option B. okay, if you see, let me check it, yes, option B. You can just eliminate even by one element, you can eliminate, I need not do all these things. okay, now what are the values of V0 and I? okay, now because there is a dependent source, don't try to write extra equations. okay, my way of doing is very simple. See now, because this is a passive element, if you see, this current should be V0 by 6, I is V by R, yes or no? If you look here, this I is V by R, and current enter positive in a passive element, so V0 by 6. So with this I will write a KVL starting from here. If you write a simple KVL, yes, if you write a simple KVL here, that KVL is, yes, plus V0, anti-clock I am writing, plus 4 minus 2 V0, okay, and this is same V0 na, so you take plus, this is V0 by 6 into that is 4 ohms, and finally plus 12 is 0, that is the first equation. And also if you see, I am taking passive notation, V0 by 6 is this current, but I is minus of this, I is minus V0 by 6. So you solve this, yes, if you solve this, yes, you will get finally this V0 is 48 volt, and you get I as minus 8 amperes. V0 is 48 volts, I is minus 8. So you will get answer option A. okay, you will get option A. Now consider the following statements regarding the network theorems. okay, regarding the network theorems, he is asking us to take the statements. With independent source, superposition theorem can be applied, can be used only when control functions are external to the network containing the sources, so that the controls are unchanged as the sources act at one time. Now what is the meaning of this? First of all, he mentioned independent sources, no doubt, and in superposition theorem the number of subcircuits is number of independent sources. But control functions come when there is a dependent source. But he is mentioning that yes, we can apply this theorem when these control functions are external to the network, no need. We did so many problems where Vx or Ix is within the network, but is mentioning that we can do only when control functions are external to the network. No, it is within the network also we can do. So this is wrong. Now, a linear active resistive network which consists one or more voltage or current sources can be replaced by single voltage source in series with resistance and parallel to and current source in parallel to resistance. Voltage source in series is what? Thevenin's equivalent. Current source in parallel is not an equivalent. So voltage is called Thevenin's voltage and current is called. This is absolutely right. That means in this statement he gave both the definitions of Thevenin's and Norton's equivalent. Then the two resistances are same in both Thevenin's and Norton's resistance, which are obtained by removing the sources. So this is also correct. So statement 2 and 3 are correct, but 1 is not, because he is asking that dependent parameters should be outside the network. No, they can be within the network also. So I don't accept this one, but 2 and 3 are correct. Okay, statement 2 and 3 are correct. So option D. Okay, option D. Okay, then now he gave a 10 ohm resistor and a current of 2.5 ampere sin omega t. What are the values of voltage and power? He gave this omega, but it doesn't matter because he is finally expressing the answers in the given terms in terms of omega. But so omega though he gave, but he is not substituting anywhere. Chalo. First of all, he is asking voltage. Now V equal to IR. I is 2.5 sin omega t, R is 10. So V is IR 25 sin omega t. So V is directly, okay. So if you say V is directly 25 sin omega t. Then what is power? Power is voltage into current. Voltage into current. So 25 into 2.5, that is 62.5 sin square omega t. So one way voltage is 25 and current is, so option A. So this is clearly option A. Okay. Now look at the next bit here. Consider the following steps regarding multiple node electrical networks. Now when you come to multiple nodes, this is a statement I link with power systems and my subject. One way in Y bus are called Y parameters. If you see multiple node networks, replace passive elements with their admittance, because in Y bus admittance form is very faster. For Y parameters, which are short circuit admittance parameters, so this is linked question with power systems and circuits. Yes, passive networks are replaced with admittances. Admittances in parallel can be added, so this is correct. Then replace all sources and time variable with the Laplace transform, because these two-port networks are not defined just for DC or AC. It will be for any function at any frequency. So Laplace is mandatory, because you remember when I enter two ports, it is all S domain. Okay, for any signal. Transfer function analysis is for any signal. Then replace transformed voltage sources with transformed current sources, because in admittance form KCL we apply. Admittance form KCL we apply. KCL means better convert all voltage sources to current sources by using source transformation. That is also true. That is also true. If possible, only we do that. But yes, replace all transformed voltage sources into current sources. So writing KCL will become easy. So according to me, all three are correct. Okay, all three are correct. Okay. So with this, I conclude networks. Two bits are relatively derivative, but remaining are easy. Okay. Now I will start with the next. I request my next faculty to take over. Okay. Just give us 2 minutes time.
Okay, in today's paper, we got total 12 questions from signals. Let us see the models. What is the linear convolution response? Why 5? He is expecting output at 5 for the given input and system. So, when you solve the samples of the input, one by one sample by substituting each index n value 0 like that, we are going to get samples like 0, 1, 1, 0, minus 1, minus 1. Of course, h of n is already given. You are all aware to follow that sum by column method, but that will eat your time. From the given options, let us decide the answer. Even if all samples of h of n are 1, when you are doing that product by using sum by column method, what is the maximum number that is possible? 9. But there is no chance for that number 9 because some of the amplitude levels are negative. So, if it cannot be 9, it cannot be other numbers like 14, 28 also blindly 0. Otherwise, if you want, you can enjoy that method. Sample by sample product we have to follow. That will take time. One by one sample product, sum by column method. After that, check the output at 5 by general method. But because some of the amplitude levels are minus 1, even if you do multiplication and addition, there is no chance for these numbers. Output at 5 is 0. Okay. Let us see the next one. By using 3-point DFT of the sequence Hn equals to a power minus n, where a is mentioned to be 1.369. 1.369 whole power minus n, indirectly, roughly I am saying, it is 0.7 whole power n. It is mentioned 3 point. Okay. So, the samples are like by substituting the index value n value 0, 1, next is 0.7 whole power 1 whole square is 0.49. So, these are the actual index 0, 1, 2. What is the first option given? He is saying H0 plus H1 plus H2 is 4. By adding the sample values of the spectrum, he is saying the result is 4. According to IDFT definition, small h0 is 1 by n sigma k equals to 0 to n minus 1 hk. 1 by n sigma hk. He has given this value. What is h0 already we have? What is h0? 1. But he is saying answer is 4. It cannot be the option. But we are aware it obeys conjugate symmetry property. Hk is h star of n minus k. Hk is h star of n minus k. Period t is mentioned to be 3. So, what happens if I substitute k plus 2? If I substitute k plus 2, it is simply h conjugate of 1. Substitute k plus 2. So, which is the best option there? Option D. By giving Laplace, it is asked us to get the initial and final value. Apply the theorems. What is initial value theorem? Limit s tends to infinity, s into x of s. So, when you apply extra s multiplier cancellation, 7s plus 5y, 3s plus 5. When you take s common, it is going to produce 7 by 3. When you apply final value theorem, limit s tends to 0, s into x of s. Again ss cancellation, s plus 0 in the same expression, s plus 0 means that is producing the answer like 6 by 5. That is what asked, initial value and final value. This is the given Laplace expression. We have to find out the time domain signal. Okay. Generally, our habituated enjoyment is what? A by s, b by s plus 1, c by s plus 2 whole square, d by s plus 2. Of course, we are going to solve for that residues a, b, c, d. Okay. Generally, after solving, we are going to get the numbers like 1 by 2, minus 2, 1, 3 by 2. So, this will also eat our time. So, which is the best method? Let us apply final value theorem. What is final value theorem? Limit s tends to 0, s into x of s. So, limit s tends to 0, 2 by s plus 1 into s plus 2 whole square, that is indirectly 2 by 4, half. So, final value is half. Observe which option will have that chance. X of t as t tends to infinity must be 0.5. When I look at the first option, 0.5 as it is, e power minus infinity 0, t e power minus 2t graph like this roughly. There also it is tending to 0. Here also it is 0, 0.5. 0.5 is satisfied for option A. Let us see second option, 0.5. Here t place infinity means it is getting to infinity. Okay. So, like that if you solve without wasting your time, option A is the best possibility. Otherwise, you have to enjoy partial fraction. Okay. Apply final value theorem, easily we are in a position to decide which is the best possible option. Okay. Yeah. Sampling. Ideal sampling, natural sampling, flat top sampling. Ideal, natural and flat top are standard methods. In ideal sampling, we try to multiply x of t with a periodic impulse train, x of t with a periodic impulse train. Okay. Whereas in natural sampling, we try to multiply the same arbitrary signal. We are multiplying by which term? A rectangular pulse train. That is also called as chopper sampling. Okay. This is natural because the original analog signal is chopped off. In flat top, we are trying to apply the ideally sampled signal to a simple zero order whole circuit, a rectangular pulse circuit, which is generally called as sample and hold circuit. We are giving that to a sample and hold circuit. So, let us do that matching. Natural sampling uses multiplication or chopping principle. Flat top sampling uses sample and hold. Ideal sampling, normal multiplication with impulse train. 3, 1, 2 is the combination. 3, 1, 2. 3, 1, 2. Yes. Which of the following properties of convolution exhibits the result of superposition principle? He wants to do simple addition, superposition. He wants to highlight on superposition. Commutative is like xt convolved ht is ht convolved xt. Distributive chance is there because when you try to apply input to a simple addition, a into b plus c is a into b plus a into c, that way here you can say xt convolved h1t plus h2t can be written as xt convolved h1t plus xt convolved h2. As he is highlighting the words superposition, chance for distribution only. Associative, you are aware, xt convolved h1t in one bracket convolved with h2t can be written as xt convolved combinedly h1t convolved h2. As he highlighted this word superposition, so the best possible option is distributive property. So, other questions will be handled by other faculty member, Mr. Aditya.
So, let us look at the other questions from signals and systems. Here he says the signal space should be divided as. If you read each and every option, now you look at a signal, it says periodic only. Signals can be periodic as well as aperiodic, it is eliminated. And option B says non-periodic, it can be periodic or aperiodic. And if you look at D, he says neither periodic nor non-periodic. This is also eliminated. You can see through elimination of the options, The only possible option is option C. Whereas the system should be either time scaling or time shifting. Yes, the systems can do time shifting and the time scaling operations. If you look at this impulse response, so look at this point at n equal to 2, it shows symmetry. So whenever you are trying to find the frequency response, or whenever you are trying to find the phase response of the system, this symmetry is going to help you. H of n maintains the symmetry about n equal to 2. This simple observation will directly give you the phase response of the system. So what's the phase response of the system? Since it shows a symmetry about 2, the phase response is minus 2 omega. It shows linear phase. Now once you know the phase response, the group delay is given by this formula, minus d by d omega of theta of omega. If you take the derivative and then put a minus sign before that, what's the derivative of minus 2 omega? It is minus 2, and into minus is 2. So its group delay is 2 now. If you look at this, he gives the impulse response, he talks about the nature of the system. So I see u of minus t in my expression, which leads to non-causal system. So it is non-causal, and when u of minus t is multiplied with e power minus 2t, if you try to draw the impulse response, it leads to something which is not absolutely integrable. When the impulse response is not absolutely integrable, it is an unstable system. So because of u of minus t, non-causal, because of 2 by 3 e power minus 2t multiplied with u of minus t, it's an unstable system. So where is that option? It is option D. Now the input to the LTI system is given. So what's the input? The input is in the form of sin t, and they also gave the impulse response, okay, and they are asking what's the output. So if you have a good practice, it doesn't take much time, you know. So the frequency of the input is 1 radian per second. So at the output also you will have the same frequency. So I can easily eliminate A and B because the frequencies don't match. And if you look at C and D, here the input amplitude is 1. So you need to find the amplitude of the output. Like output is also sinusoid, you need to find the amplitude of the output. But since C and D have the same amplitudes, I don't need to find that as well. So what next? So definitely this system introduces some phase angle. So because to find that phase angle, you need to find h of s, replace s with j omega, and that in that omega place you have to put the input frequency, which is 1. Definitely it gives you some phase angle. Definitely some phase angle, which turns out to be 26.6 degrees. So without any problem solving, the output of the system is this. And then they gave a sequence x of n. They are asking you what is x of 2n. So we know x of 2n is called decimation, which is like a compression operation. So what we do is, since decimation by 2n, we pick every second sample. So n equal to 0 will our reference. So let me write x of 2n. So I pick every second sample. So this is 1. Next, so I'll just highlight every second sample. So see how simple is this problem? Every second sample, every second sample, every second sample, and from there onwards every second sample is 0. And if you go to the left, every second sample is 0. Whatever I highlighted, you write them 1, 1, 1, 1, and then put a arrow mark. But there is no option like this 1, 1, 1, which has 4 samples like this. If you carefully observe this, if you know how to draw u of n minus u of n minus 4, when you subtract those two sequences, what you get is 1, 1, 1, 1, which starts at n equal to 0, ends at n equal to 3. Look how simple is this question. Now they gave a sequence x of n. They're asking what happens if it, like when it revolves 4 units in a circular shift operation. So what I'll do is, he's talking about circular shift. Let me repeat the sequence. So 1, 2, 4, 8, 16. Let me repeat it again. So 1, 2, 4, 8, 16, and so on. So the arrow was here. If I shift this towards like any direction, whether it is left or right, doesn't matter. You try to shift it 4 units. So 1 unit, 2 unit, so 2 units, 3 units, 4 units. So if it is shifted here, then the sequence is 16, 1, 2, 4. So let me write that. If you shift it by 4 units, the new sequence What's the new sequence? The new sequence is 16, 1, 2, 4, 8. Is this option there? Yes, which is option D. Can you see those values? It is matching. Now, you can also shift towards right. So, if you look at the original sequence is like this. Okay, let me write the original sequence once again. So, instead of shifting, let's shift the other side. So, let me write it once again. 1, 2, 4, 8, 16, 1, 2, 4, 8, 16. Let me put arrow here. So, let's take this sequence and then shift 4 units like this. So, 1 unit, 2 units. So, here was the arrow. So, when you shift it 4 units, 1, 2, 3, 4. So, it points 2. And then from here onwards, you just collect 4 or how many values? 5 samples. You collect 5 samples here. It is 2, 4, 8, 16, 12. Is there any other option? 2, 4, 8, 16. Sorry, it's not 12, it's 1 actually. So, you can do that modification. So, this is the other sequence. Since he has not mentioned us the direction, both can be the right answers for this. So, it is this as well as this. You can choose any one of them. So, these are the questions from signals and systems. And then we have Sarvan sir taking communications. So, let me, here I think we have the slides. So, sir will continue.
Is my voice clear? Yeah. Sorry for the delay, a small technical glitch has happened. So, here the data is given to you, the current on a diode is given, it is given to you as 12.5 milliamps, and you are also given the bandwidth which is 10 megahertz, that means 10 power 7 hertz. So, he is asking what is the emission current. So, obviously it would be RMS value, and this is given as square root of 2q, the diode current multiplied by bandwidth. So, q represents the charge of electron, ID is given to you, bandwidth is given, just substitute and you will get the value as 0.2 microamps. So, direct straightforward simplification. Current when you are calculating on this element. Okay. So, your right option would be C. Right. Let us see the next question. This is also a very simple question. A transmitter supplies 10 kilowatt power to an aerial when unmodulated. That means he is talking about the power taken by the carrier component, which is 10 power 4 watts. When unmodulated, what is the power radiated when modulated at 30%? So, mu is given to you as 0.3. So, what is the formula we have? Pt is equal to Pc into 1 plus mu square by 2. Just substitute all the values. This value will be 10 to the power of 4 into 1 plus 0.3 whole square will be 0.09 divided by 2. Options are given in terms of kilowatts. So, you will get 10.45 kilowatts. That is it. This is also a straightforward formula bit only. Most students will have done it correctly. Okay, right. Let us see the next question. Consider the following statements regarding AM versus FM. So, here the question is related with theory bit, related with AM and FM modulation schemes, AM versus FM. So what is the data given to you here? Process of demodulation is complex in AM broadcasting than in FM broadcasting. Actually, AM schemes are much simpler when compared with FM. So the demodulation of AM is actually simple than FM. So whatever the statement he is telling here is a false statement. In FM broadcasting, stereophonic transmission is possible. We are using for wideband FM. It is absolutely true. AM broadcasting system has poor noise performance. This is also true because the figure of merit values for AM is the least values when compared with any other modulation scheme. So which of the following statements are correct? So definitely 2 and 3 are correct. So you can go with option A. Right. Let us see one more bit. Signal voltage and noise voltage are given to you. So it is very clearly mentioned they are voltages. Okay. What is signal to noise ratio? So whenever you calculate signal to noise ratios, these are calculated in terms of powers. If it is a logarithmic scale, you will take 10 log. So here the signal to noise is normal value only, because you are given with voltages, it is 0.923 into 10 to the power of minus 3 whole square will be the signal power, whole divided with the noise power will be 0.267 into 10 to the power of minus 3 whole square. That is the only logic that you have to use here. Everything is simple. So if you calculate, you will get around 11.95. So your correct answer will be option D. So these are the questions given in today's paper. I hope you have done these questions. These are very simple and straightforward bits. Thank you.
Right. Now I am going to give the key of questions from electrical and electronic measurements. The question here is, in an electrodynamometer type wattmeter, current coil resistance is given, potential coil resistance is given, and the current coil is to the load side. Current coil is to the load side means you need to understand that is MC short connection. Current coil is on load side. And what is the formula? Percentage error equal to IL square RCC by VL IL. Cos phi anyway it is given as unity power factor, so into 100. All values are given directly. If you substitute the values, you are going to get the answer as 0.48. So option B. Right. Next question is a direct question. What is the expression for deflecting torque in a single phase induction type energy meter? This is directly option C, direct formula based question. Next one, when secondary winding of a current transfer, we have taken this question as it is, open circuited with primary winding still energized. What happens? Due to the large amount of MMF, core gets deeply saturated. Yes, first option. Next one, the purpose of start bit in digital voltmeter is to, so this is a direct question, gives zero indication on the display during start of conversion, right? Next one, in general the range of multimeter, he has given that in general, so among the given option generally we can take, right, minus 1999 to the plus 100, this is a general range in the corresponding digital multimeter, right? Next one is here it is a numerical question. A single phase range laboratory type potentiometer has 18 step dial. Each step represents 0.1 volt, 10 ohm resistance, and 11 turns are there. Each resistance having 1 ohm per turn. The slide wire has 100 divisions, and he is asking what is the corresponding range. Now you need to find out the V dial first. What is the V dial value? 18 into 0.1, so that will be, what is that value? 1.8 volt. So we need to find out the V dial first. After that, R wire. What is the R wire value? So simply 11 into 1 ohm. So totally 11 ohm. And after getting this, if you are using the formula V wire by V step, V wire by V step is equal to R wire by R step, R wire by R step. If you simplify this, you are going to get V wire is equal to 0.11 volt. You are going to get 0.11 volt. Finally, V is equal to, already correspondingly we are getting, we have got 1.8. So simply 1.8 plus 0.11. If you are adding this, 1.91 volt. So answer is C. Normal step by step procedure. Right. Next one is right. This is very simple one. In this, match the following questions, whichever the specific one, that's kindly consider. Here Anderson's bridge is there. Anderson's bridge. That is what? This is the formula. If you hold this R2, if you see the options, R2 is only with 1. So directly first option. No need to worry about the other things. Right. Next one. It is PMMC question. TD is equal to BIN into A. BI means V by R into N into A. If you use this formula, you are going to get R value. Simple. All values are given. You can find out. You will be getting the value around 50 into 10 power 3. So therefore, this is the answer. Right? Just check it. Calculated value and check the corresponding option. 5 kilo or 50 kilo. Kindly verify. And then consider the following statements. Right? Moving iron instrument. In the moving iron instrument, what is that? Moving iron instruments have uniform scale. Right? Here he is asking which are correct. These are having which one? Non-linear scale, but is given as uniform scale. So therefore, in the options 2 should not be there. So this is wrong and this is also wrong. And then correspondingly, let us go for this. Moving iron instrument have their deflection proportional to the square of the current. Correct? Whatever be the polarity of the current coil, the deflection of the moving iron instrument is in the same direction. Why? It is suitable for both. Yes, correct. So therefore, option is 1 and 3. Next one, here. Consider the following statement regarding induction type instruments. If you see this, right, this will be the wrong statement and 2 and 3 will be the correct one. So automatically answer will be 2 and 3, option B. Next, last question here is, the electron beam in a TV picture tube is 10 power 5 electrons per second. What is the voltage V0 needed to have the corresponding power? What is the current formula? N into E. What is N value? 10 power 5 15 electrons are given into electron charge 1.602 into 10 power minus 19. You will get the corresponding current value. After that, voltage is equal to P by I. Power is given, current. If you simplify this, you are going to get the value as 25 kilovolt. So answer is this. So these are the questions from the measurement subject.
Yeah. Hello everyone. Let us discuss the questions from power electronics and drives. Total 12 questions they asked. Yeah. This is the first question. The diode circuit consists of a diode in series with a switch S1, resistance given R 44 ohm and capacitance C 0.1 microfarad. Capacitor has an initial voltage VCO at t equal to 0, it is 220 volt. If switch S1 is closed at t equal to 0, what is the energy dissipated in resistor R? So they are asking what is the energy dissipated. Circuit is like this. We are having a diode, a switch and a resistor and a capacitor. This capacitor is initially charged like voltage VCO. This resistor R, switch is closed at t equal to 0 and this is diode D. They are asking energy dissipated in this resistor. Now at t equal to 0, when we close the switch, what will happen? This capacitor will discharge, right? Capacitor will discharge, means capacitor will give the energy and that energy will be dissipated in this resistor. We know in case of capacitor, energy is equal to half into CV square. So it is E equal to half into C into VCO square. So it is half into, yes, capacitor value is 0.1 microfarad and VCO is equal to 220 square. So from this I can write it is, if you simplify this, you will get it as 2.42 millijoules, right? Simple question, right? Next, means capacitor is giving energy and that energy is dissipated in a resistor. All right. So option D is the correct option for this question. Option D is the correct option. Next, yeah, question number 80. Yes. Which of the following is not a limitation of MOSFET? Not a limitation, they are saying. Here options are high on-state drop as high as 10 volt. High on-state voltage drop, we know MOSFET is a majority charge carry device and it is having a more on-state resistance. Due to the high on-state resistance, it causes a high on-state voltage drop. So that is a limitation of MOSFET. So they are asking not limitation. So option A will not be your answer. Unipolar voltage device. Yeah, we know your transistor family devices are unipolar devices, right? And due to that, those devices we cannot use in a converters where input is a AC. So unipolar device is a limitation of MOSFET. Next, slower switching speed. We know MOSFET is a device which is having a high operating frequency, that is high operating speed. So slower switching speed is not a limitation, right? So option C is the correct option for this. And last, lower off-state voltage capability. Yes, voltage rating of MOSFET is comparatively low, right? So that is a limitation. So not a limitation means option C. Correct answer is option C. Next, yeah, two BJTs are connected in parallel to share the total current 25 ampere. Check similar type of question we discussed during our classroom sessions. In that question, instead of BJTs we discussed for MOSFETs, but here simply they have changed that MOSFET with a BJT. Collector to emitter voltage of T1 and T2 are 1.5 volt and 1.75 volt respectively. What is the difference in emitter current sharing by two resistors when the current sharing series resistances are RE1, RE2 given? So here we are having the circuit this type. This is load, supply voltage and two BJTs. Yes, we are having the two BJTs. This is VCE1, VCE2, RE1 and RE2. Current here is IE1 and here it is IE2. This total current is I, right? Now here, yes, the total current is 25 ampere. So I can say that here I equal to IE1 plus IE2. I equal to IE1 plus IE2. So I is 25, 25 equal to IE1 plus IE2. Consider as equation number 1. Second, we know voltage across the parallel branches is same. What is the voltage across this branch? It is VCE1 plus IE1 into RE1. Voltage across this branch is VCE2 plus IE2 into RE2. So I can write it as VCE1 plus IE1 into RE1 equal to VCE2 plus IE2 into RE2. Now here put value. VCE1 is 1.5 plus IE1 into RE1. RE1 is 0.25. VCE2 is 1.75 plus IE2 into RE2. RE2 is 0.35. So from this I can form the equation, second equation, that is minus 0.25 equal to minus 0.25 into IE1 plus 0.35 into IE2. Consider as equation number 2, right? Two equations, two unknowns, we can solve this, and from after solving we can get it as IE1 equal to 15 ampere and IE2 is equal to 10 ampere. So what is the delta IE? There is difference in the emitter currents, that is IE1 minus IE2, that is equal to 5 ampere, right? 5 ampere. So correct answer for this question is option B. Option B is the correct option. All right. Next question. The typical upper rating, maximum rating they are asking for a power transistor, and in that specifically they are asking for the MOSFET R. We know MOSFET are not preferred for high power applications. It is having a low off state voltage blocking capacity. So here MOSFET, practical case, my MOSFETs are having the maximum possible voltage rating is in the range of 600 volt up to 600 volt, and current rating is approximately 40 ampere, right? So here suitable option is option A. This is informative question, right? Next, the firing frequency of relaxation oscillator. Yeah, this question is related to the UJT oscillator triggering for a SCR, right? Now for UJT oscillator triggering of for SCR, if you check the circuit diagram, this is our circuit diagram. R1, R2, this voltage is VBB, this resistance is R, and this is capacitor, this voltage is VE, right? What happens in this circuit? Till the instant my capacitor voltage reaches VP value, my capacitor will be charging. Once this voltage VE, that is capacitor voltage, becomes equal to VP, then my UJT will start conduction, right? UJT will start conduction. So here, in order to find the minimum and maximum values of the resistance, I can write here resistance value depends on this side voltage minus this side voltage, right? So here I can write resistance R max equal to VBB minus VE, but this maximum resistance will limit my current, right? So here current is equal to IP. Sorry, we need to take the difference of the voltages, divide it with the current, right? So it is minus VP upon IP is equal to VP is nothing but peak voltage, IP is nothing but peak current, right? Next, so VBB is 14 volt, yes, sorry, 20 volt they have given, minus VP is a 12 volt upon current is IP, that is 0.65. milliampere. Yes. If you simplify this, you will get it as 12.3 kilo ohm. 12.3 kilo ohm. And similarly, R min is equal to VBB minus VV. VV is nothing but valley voltage upon IV, current corresponding to the valley voltage. It is 20 minus VV is 1.5 upon IV, that is 2 into 10 to the power minus 3. If you simplify this, you will get it as 9.25 kilo ohm, right? So correct answer is option A. Option A is the correct option. Fine. Next. Yeah, the capacitance CJ2 value of a reverse bias junction J2 of a thyristor is independent of off-state voltage. Limit value of a charging current to turn the thyristor, actually to turn on the thyristor it should be, is about 15 milliampere. If the critical value given, what is the value of the junction capacitance? Yeah, simply use I equal to Cj into dV by dt. Now what is the current value? 15 milliampere. Cj we need to find into maximum voltage dV by dt. It is 750 volt per microsecond. 750 upon 10 to the power minus 6. If you simplify this, you will get it as Cj equal to 20 picofarad. So actually answer is 20 picofarad. But if you check the options, here this Cj is nothing but a minimum value of the capacitor. So value of the capacitor which is slightly greater than that of this value, right, is acceptable, because your I is directly proportional to the Cj. More the Cj, more is the current. And here whatever the charging current they are given, limit value of the charging current is nothing but minimum value of the current required to turn on the SCR, that is 15 milliampere. So this Cj is corresponding to the minimum current, minimum possible current, right? So that is Cj min. So near to this, if you check the options, near to this the possible value is a 50 picofarad, right? You can select option C. Next, a single phase half wave control rectifier with R load. Half wave control rectifier with R load. Yes, half wave controlled rectifier and single phase they are talking. Yeah, is supplied from 230 volt 50 Hz AC source. When the average DC output voltage is 50% of maximum possible average DC output voltage, what are the firing angle of the thyristor and average DC output voltage respectively? Okay, so alpha and V0 average they are asking. It is given that V0 average is equal to 50% of maximum V0 average. 50% of maximum V0 average. Now in half wave rectifier, what is the V0 average expression? It is Vm by 2 pi into 1 plus cos alpha. 1 plus cos alpha is equal to 0.5 into, what is the maximum V0 average? Output voltage is maximum when alpha is 0 degree, that is equal to Vm by pi, right? Vm by pi. So now if you check from this, Vm cancel out, pi will get cancel out, right? So it is, I can write this as, if from this if you simplify, you will get alpha equal to 90 degree. So my alpha value is now 90 degree. Now corresponding to this alpha, what is the V0 average? V0 average is Vm by 2 pi into 1 plus cos alpha. 1 plus cos alpha. So it is the Vm is a 230 root 2 upon 2 pi into 1 plus cos 90. Cos 90 is 0, right? So it is like 230 into root 2 upon 2 pi. If you simplify this, you will get it as equal to 51.78. 78 volt. So correct answer is option C, right? Simple question. Next, yeah, a single phase semi converter is supplied by 200 volt 50 Hz and is connected with RLE load. RLE, R given, E given, L value is large, means highly inductive. Load current is constant. What is the average output current at alpha equal to 90 degree? At alpha 90 degree, what is the average output current they are saying? That is the I0 average. So first let us find V0 average. V0 average for highly inductive load but single phase semi converter. It is Vm by pi into 1 plus cos alpha. So from this I can write Vm is 200 root 2 upon pi into 1 plus cos of alpha. Yes, alpha is 90 degree. Cos 90 is 0, right? So you will get it as a 200 into root 2 upon pi. This is my V0 average. V0 average. Now what is I0 average? I0 average is equal to V0 average minus E by R. So put the value, it is 200 into root 2 by pi minus E is a 80 volt upon R is a 15 ohm. Check this, root 2 by pi is a 0.45, 200 into 0.45 is a 90, 90 minus 80, 10, 10 by 15, that is equal to 0.66 ampere. So your I0 average is 0.66. So option C is the correct option. Next, yeah, a step down chopper has a load resistance of 20 ohm and input DC voltage is a 200 volt. When the chopper switch is on, the voltage across semiconductor switch is 2 volt. Means switch is causing a voltage drop, on state voltage drop of 2 volt. Chopping frequency given, duty ratio given. Then what is the average DC output voltage? V0 average they are asking. Yeah, for step down chopper, when switch on state voltage drop is non-zero, then how is the output voltage? Check, it is like this. And this voltage is now Vs minus Vt, that is on state voltage drop. Vt means on state voltage drop. Without on state drop, this voltage is Vs. Now what is V0 average? V0 average is simply D into Vs minus Vt. D is a 0.4 into Vs minus Vt. Vs is 200 minus Vt is 2 volt. So if you simplify, you will get it as 79.2 volt. But if you check the option, right, 79.2 volt is not present. So you need to go for near to this. So it is 80 volt. Option B is the correct option. Option B is the correct option, right? Yeah, next question. Yeah, what is the expression for distortion factor in inverter? We know in practical inverters, my expected output is a sinusoidal. But my practical inverters are not giving me output in terms of non-sinusoidal. So we are having the various performance parameters, right? In that, one of the parameter is the distortion factor, right? So we are having two related to distortion factor. We are having the distortion factor for a particular harmonic as well as distortion factor of a total output voltage waveform. So for total output voltage waveform, your distortion factor is a, yes, it is summation n equal to 2, 3, 4 up to infinity. I am adding the output voltages, right, due to all harmonics. It is Vn upon n square to the power 1 by 2 upon, it is fundamental, that is V1, right? So your correct answer is option B. It is straightforward, right? Next, a separately excited DC motor is controlled by a single phase full converter which is supplied from 440 volt 50 Hz AC supply. If the field current is fed through the single phase full converter with a 0 degree firing angle, the delay angle of a armature converter is a 30 degree and load current given 20 ampere. What is the field current? They are asking field current, and here it is given that my field is supplied or fed through the single phase full converter, but alpha is 90 degree and the current waveforms are ripple free. Current waveforms are ripple free, they are saying. Now converter field winding of your separately excited DC motor is fed by single phase full converter. For that, alpha given 0 degree alpha equal to 0 degree. So from that I can write average voltage across my field winding Vf average is equal to Vm 2Vm by pi, right? It is Vm by pi into 1 plus cos alpha. If you put alpha 0, you will get 2Vm by pi. So this 2 into Vm is 440 into root 2 upon pi. This will give me Vf average. And now from this I can find If average. It is equal to Vf average upon Rf, right? It is a 2 into 440 into root 2 upon pi upon Rf. Rf is a field winding resistance 140. If you simplify this, you will get it as 2.83 ampere. 2.83. So correct answer is option A. Option A is the correct option. And next question. Yes. Yeah. Consider the following statements regarding the AC drives. AC drives require simple control algorithms than DC drives. No. My AC drives are more complex than that of the DC drives. So their algorithm is also complex. So statement 1 is not correct. Power converters used in AC drives are relatively simple and less expensive. In AC drives, we are using the inverters, AC voltage controllers, cycloconverters. Those are more complicated. Next, so second statement is also not correct. And VSI, CSI, AC voltage controllers, PWM inverters are used in variable speed induction motor drives. Yeah, in case of induction motor speed control, we require the converters which can give me the output in form of variable AC. So VSI, voltage source inverter, current source inverter, AC voltage controllers and PWM inverters, these will give me the speed. These are used in speed control of induction motor. So statement 3 is the correct. So which of the following is correct means only 3. So that is option B. Option B is the correct option, right? Yeah. So these are the questions from the subject of power electronics.
Right. Now I am going to discuss about electrical materials. Now here is the first question. In this question, they are asking about the drift velocity of an electron. So in this question, we can use current density is equal to NeVd. So Vd is equal to drift velocity, that is J by Ne. In the question, J is given, that is 10 power 7. Number of electrons is given 10 power 28 and electron charge 1.6 into 10 power minus 19. If you solve this question, you will get the answer D. D is the correct answer for this question. Okay, D is the correct answer for this question. Now, the next question, this question is related to the magnetism, magnetic field. See, which one of the following is generated by a supplementary pressure movement of a conduction electrons that appear when the material is introduced in the magnetic field. So if you keep the material in the magnetic field, due to the electrons there is a magnetic moment that we call it as a Larmor magnetic diamagnetism. So D is the correct option. Now, the cement of gold and silicon oxide is obtained by the deposition on glass support and consists in conductive particles of gold speeded in amorphous matrix of silicon dioxide. So here for this question, A is the correct answer. Okay, direct straightforward question. Now here is a question. There are different insulating materials given and their limiting temperatures are given. So class A material has maximum temperature 105, okay na, and class Y is 90
So you can take P is 4. Out of these 4 options, P is 4 and Y is 3. So D is the correct option for this question. D is the correct option for this question. Now next, this question is a formula based question. So magnetic permeability, relative permeability, straightforward formula is given. So B is the correct answer for this question. Now if this question is related to the ferrite, in this question, okay, ferrites are non-linear magnetic materials. So this statement is wrong. Next, the value of saturation induction and Ramnant induction are lower. Okay, we'll keep aside this one doubt. The magnetic permeability is lower. It is not correct. Magnetic permeability is high and less sensitive to the action of external magnetic field. So this is not correct. So they are asking about the correct statement. So only 2 statements, second statement is correct. The value of saturation magnetization is lower than ferromagnetic material. So second option is B is the correct option for this question. Now, and this question is related to the electrical conductivity. Electrical conductivity of copper. You can use this formula, sigma is equal to Ne square T by M. Ne square T by M, complete data is given. Number of electrons, how many given? 8.5 into 10 power 28 into electron charge 1.6 into 10 power minus 19 whole square, and time is given 2 into 10 power minus 14 seconds. By mass of electron is given 9.1 into 10 power minus 31 kg. So if you solve this question, you will get directly option D. D is the correct option for this question. Okay, D is the correct option for this question. Otherwise, you can remember the electrical conductivity of copper is 6 into 10 power 7 ohm meter inverse. Right. Now this question is related to the 2 different metals, silver, copper and gold, and their theoretical density values. So generally aluminum is a low density material, so that aluminum is 2.7. So S is equal to 1. Out of these 4 options, S is equal to 1, only one option, so that C is the correct option for this question. Now the next question, this question is related to the impurity materials. See, resistivity of an impurity is equal to resistivity of total minus resistivity of pure. Okay na? So let us consider 4% impurity resistivity. You can take total is 7 into 10 power minus 8 minus 1.8 into 10 power minus 8. So you will get 5.4 approximately. So from this here 4% of impurity material. So 1% of impurity material if I want. So 5.4 or 5.2 you will get 5.2 into 10 power minus 8 by 4 you will get, then from that approximately 1.3 into 10 power minus 8. So here D is the correct option for this question. D is the correct option for this question, simple question. Now here is a question related to the atomic bonding. If 2 ions with the same ionization potential form a bond, then it is then this bond mostly probably ionic is given, but it is not ionic, it is covalent actually. Next, with increasing difference of the ionization potential, the bond will be more ionic. Yes, it is correct. So first statement is wrong, second statement is correct. If the atoms or molecules has completely filled outer shells, then the bonding between the atoms or molecules will be primary bond. It is not correct. Okay, if all the electrons are filled in the outer orbital, they are become noble gases, so they are intermolecular, secondary bonds are formed, so that this statement is also not correct. So only B is the answer for this question, only second statement is correct. B is the answer. Now this question is related to different metals and their resistivities. You can take let us consider the copper resistivity of copper. Just now we calculated the electrical conductivity of copper, we calculated 6 into 10 power 8 or 7. You can see this question. Okay, you can see this question here, 6 into 10 power 7, right? 6 into 10 power 7, right? From this, rho is equal to 1 by sigma, that is 1 by 6 into 10 power 7. If you solve this question, so we will get the copper is 1.56 into 10 power minus 8. So and the copper is 1.56 into 10 power minus 8. So you can take R is equal to 2. R is equal to 2, only one option is there, so that C is the correct option for this question. C is the correct option for this question. Now the next question, this question is related to specific gravity of copper and aluminum. We know that aluminum has a low specific gravity, so 2.7 aluminum, okay, copper has 8.8. You can see here specific gravity of aluminum, R is 4. You can take R is 4, 2 options are there. Again copper you can take 8.8, so P is equal to 2, so B is the correct option. B is the correct option for this question. These are the static values you should remember. Okay, na? Then magnetic flux density of on surface of iron phase is 1.6 Tesla, which has a typical saturation level value for ferromagnetic material. What is the force density function? Force density is equal to B square by 2 into mu naught. B square by 2 into mu naught. So 1.6 whole square by 2 into 4 pi into 10 power minus 8. 4 pi into 10 power minus 7. So by solving this, you will get the answer B. B is the correct answer for this question. B is the correct answer for this question. So these are the questions from the electrical materials.
Let us see questions from digital electronics. The question is, which one of the following code counter is used to remove the ambiguity during the change from one state to the another counter to next during the state transition? So what we need to understand from this is when there is a change in a state, if more number of flip-flop states is changing, there is more ambiguity. So if you observe that only in gray counter there is only one bit change which is going to be having lesser ambiguity when you are designing a gray counter. Let us see next question. Which one of the following gates is most commonly used in the design of a system bus? So obviously when a system bus is observed, so parallelly it is right running, the data is traveling on parallel lines. When parallel lines are there, obviously there is a coupling capacitance. When there is a coupling capacitance is proportional to the length of this, because the cross section area is depending on this, then if you are adding buffers, then crosstalk can be reduced. So when you want to reduce the crosstalk, obviously we can introduce a buffer, because without changing the functionality it has to transmit the signal without the effect of crosstalk. When crosstalk has to be reduced, then net length must be reduced. For that we can introduce buffer, which is answer is D. Next question. Consider the following statements regarding bistable multivibrator. So obviously we know that bistable multivibrator can be used as a memory element, and the same can be used in a flip-flop. Flip-flop can be used as a frequency divider circuit. So 1 is correct, 3 is correct. It cannot be used as a sine wave generator, so which cannot be correct. So answer is A. Let us see next question. What is the percentage of resolution of 8-bit DAC? So when you say that n bit 1 by 2 power n minus 1 into 100 is a percentage of resolution. So it is equals to 1 by 2 power 8 minus 1 into 100 is equals to 1 by 255 into 100 is equals to 0.392 percentage. Answer is B. That's all from digital electronics.
Students, let's look at the solutions from engineering mathematics. So here I'm going to deal with probability part. A box contains 10 screws, 3 of which are defective. So total are 10. Defective, how many? 3. So the ones which are not defective obviously are 7. Then what's the probability that neither of the 2 screws is defective? And how are the screws drawn? 2 screws are drawn at random without replacement. So they have drawn without replacement, and they want both of them, neither of the 2 screws is defective. Neither of the 2 screws defective means both should be, they have to be from good parts or good screws. So what's the answer? It is simple, 7C2 by 10C2. So which is 7 into 6 by 10 into 9. So do we have any answer this way? So let's cancel this in 3. So 3 2s are, 3 3s are 30, and then 14. 14 by 30, yes, we have that option, which is option B. If a random variable x, which is sum of 2 numbers of 2 fair dice turned up, is discrete, then what is the probability the sum of at least 4 and at most 8? Now this is a very simple question actually. If you look at the, when through 2 fair dice are thrown, you look at the sample space, you have 36 points which are like this: 1 1 to 1 6, so on, 6 1 to 6 6. You would have discussed, like you would have seen this many number of times. If x represents the sum, then the sum takes values like 2 3 4 5 6 7 8 9 10 11 12. And you also know their probabilities. It actually maintains a symmetry. So here it is 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, and then 6 by 36. And then the probability decreases 5 by 36 and so on. I don't write the others because he says the sum should be at least 4 and at most 8. So you need to focus on these observations and the corresponding probabilities. If you add them, it's over. Come on, since the denominators are same, just add the numerators. 3 plus 4 7, 7 plus 5 12, 12 plus 6 18, 18 plus 5 23. So the answer is 23 by 36. Says a bag contains 7 green and 5 yellow balls. Okay, 7 green and then 5 yellow. And 2 balls are selected at random, one at a time. So how are the balls drawn? One at a time. What's the probability that 2 balls are of different colors if the selection is made with replacement? So the keywords are with replacement, and then they are drawn one at a time. So they want it to be different. So it could be like this. It could be green yellow or yellow green, right? It can be like, you need to consider these 2 cases because these are the cases where you have different objects. So what's the probability that you draw a green followed by yellow? So it is 7 by 12 into yellow, because it is with replacement. Whatever you draw, you'll again put it in the bag. It is 5 by 12 plus yellow green is like same thing, 5 by 12 into 7 by 12, which is 2 times 7 into 5 by 12 into 12. So this cancels this by 6 times. This is numerator 35, denominator is 72. Do we have any option like that? Yes. Here the conditional probability is asked. Okay, conditional probability expression. This is very simple. It is probability of A intersection B by probability of A. Probability of A is 0.6. We need to extract probability of A intersection B. We know probability of A union B is P of A plus P of B minus P of A intersection B. How much is this? This is 0.7 equal to, this is 0.6 plus 0.2 minus, we don't know this. So if you rearrange, this is 0.8. The probability of A intersection B value is 0.1 na, and then you put 0.1 here, it is 1 by 6 na. So which is option B. So he says x is binomial and the parameters are given, which are 16 and 1 by 2. So parameters means n value is 16 and the p value is 1 by 2. The variance is asked. There can't be any other easy question than this. The variance is given by the formula np into 1 minus p, it is 16 into 1 by 2 into 1 by 2. So this cancels and the variance that you get is 4. And he says x is a normal random variable whose mean. So here also the parameters are given. So 15 is the mean and the variance is also given, which is 6.25. If variance is this, then the standard deviation, how much is the standard deviation? It will be square root of that, which is 2.5. What is the value of x, which is 1.2 standard deviations below the mean? So first of all, we extracted sigma. How much is that? 2.5. Now what is 1.2 times sigma? 1.2 into 2.5. Can you find this? So what is 25 into 12? 250 and then 300. I think it is 3. Now he wants to know what is x value, which is 3 units below the mean. Mean is 15 and 3 units below the mean means he's talking about something like this: 15 minus 3, which is 12. This is also simple actually. Here the height is given. They say they are actually measuring some height, which is 2 minus 1.5 sin t, and then it's an open interval 0 less than t less than 3. Now it's an open interval, so what shall we do? Sin t. So this can be viewed as 3 sin t, sin let's say pi value is 3.14. So if you look at sin t graph is like this, 0, and this is pi, which is like approximately 3.14. But you are supposed to see from in the open interval 0 to 3. So how do you do it? If you want the maximum of this, then you need to put minimum value for sin t. If you want maximum value of this expression, since there is a negative sign, you need to put a minimum value here. In this interval, look, what could be the minimum value of the waveform? It is obviously 0. So as t approaches 0, this reaches to a maximum value. You can eliminate few options like A and D because it can't reach sin t. If you look at the maximum minimum value in this interval 0 and 1, it can't go up to 4 and 6. So these are anyway eliminated. Now as t approaches 0, sin t becomes 0 and then you are left with 2. So the maximum height could, like, among this, the best option is 2 meters. So this is the answer for the question. So remaining questions, Ravindra Reddy sir will continue with the discussion.
Now I will discuss about the remaining questions of the mathematics part. Continuation of the mathematics questions. It is a question from the linear algebra topic. In this question, the 3 statements are given and we are asked to choose the not correct statement, that is false statement. The correct statements are wrong answer, wrong statements are correct answer. Now check one by one option, one by one statement. The rank of a matrix equals to the maximum number of linearly independent column vectors. according to independent and dependent vectors, the rank of the matrix is same as the number of independent rows, number of independent columns, number of independent vectors. But here it is given as rank of a matrix is equal to maximum number of independent column vectors. So this is a correct statement on. The first statement is correct. Rank of A equal to the maximum number of linearly independent column vectors. So this is the correct statement, but wrong, because we are searching for the false statement. So it is a correct statement, wrong answer. The matrix A and its transpose have the same rank. It is also correct statement. Rank of A is always same as the rank of A transpose. A and A transpose will have same rank. So it is a correct statement. Statement is correct, but these two are wrong. Next, the last statement. Consider P vectors. 1, 2, 3 and so on P having n components. Each vector is having n components, means the vector is of order n, or each vector contains n elements on it. Let us consider the matrix A with the P vectors, and each vector is a column vector because it is given that column vectors on. So let us suppose x1 is the first vector, x2 is the second vector, and so on xp. There are n column vectors and it is formed with matrix. The matrix is formed with n column vectors and each vector is of order n. So how many columns are there? P columns. Each vector is of order n, so n cross p matrix. And for this matrix, according to this order, the rank of the matrix is same as less than or equal to minimum of these two, n comma p. But already here given as condition n less than p. So rank of A is less than or equal to n, and this is not equal to p since n less than p. Rank is equal to either n or less than n. That means rank is not equal to p, means all the p vectors are not linearly independent. Suppose rank is equal to p, then the p vectors will be linearly independent vectors. Here not equal means all the vectors are not independent, that is dependent vectors. But here he is saying that independent. So this is wrong statement and this is the correct answer. It is a wrong statement, correct answer, and we are asked to choose a false statement. So 3 only is the correct. Because these two are correct statements, this is a wrong statement and we are searching for wrong statement. So 1 and 2 are correct, 1 and 3 is, this is wrong. Only 3 is the wrong statement, this is the correct option. Now let us go to the next option, next problem. The eigenvector xi of n by n matrix A corresponding to eigenvalue lambda equal lambda I is a solution of the homogeneous equation. According to definition of eigenvector and eigenvalue, the eigenvector is same as the non-zero solution of the homogeneous system or non-trivial solution of the homogeneous system. One special type of system is A minus lambda I into x equal to O. It is a one special type of homogeneous system. For the homogeneous system, there are two types of solutions. One is zero solution, other one is non-zero solution. For every homogeneous system, zero solution always exists, but this non-zero solution may or may not exist. For this particular type of homogeneous system, this non-zero solution exists. Then this non-zero solution is called eigenvector of the matrix, correspond to some scalar lambda. So here the lambda is the eigenvalue of the matrix A, n cross n, and this x is the non-zero vector. This x is the non-zero vector, that is non-zero vector is the eigenvector of this matrix. So in this problem here given that for nth order matrix, n number of eigenvalues exist. For each eigenvalue we find the solution xi. That is why xi is the non-zero solution of the system. The non-zero solution of the system is the eigenvector of this matrix corresponding to eigenvalue. That is purely definition. That is why this is the correct answer. A is the correct answer. Let us go to the next problem. What is the value of the Fourier coefficient A0 for the function given below? So this is the first term in the Fourier series expansion formula, that to constant term free from the variables. The general formula of the Fourier series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a suffix n into cos of n pi x by L plus summation n equal to 1 to infinity b n into sine of n pi x by L. It is a general formula of Fourier series expansion of any function in any general interval c comma c plus 2L, may be closed or open, and we are asked to find this coefficient a naught, the quotient a naught in the Fourier series sum. Here the a naught is given by 1 by L integral integral c to c plus 2L f of x dx. But here the main interval is minus pi to plus pi. So we can divide this into 3 parts. Based on that interval, we can choose the function 1 by pi integral minus pi to minus pi by 2. In this interval minus pi to minus pi by 2, the function is sine 2x dx plus integral minus pi by 2 to 0, the function is 0, plus the last part 0 to pi, and the function is sine 2x dx. This is equal to 1 by pi, integral of this is minus cos 2x divided by 2 from minus pi to plus minus pi by 2 plus second part is 0 and the last part minus cos 2x divided by 2 from 0 to pi. Because of minus sign, first we substitute lower limit and then upper limit. 1 by pi 1 by 2 into cos 2 pi, that is plus 1. Next x equal to pi by 2, 2 to get cancelled, cos pi is minus 1 plus 0 plus 1 by 2. Again with the minus sign, first we substitute lower limit and then upper limit. Cos 0 1, cos 2 pi is 1, this is 0. So finally minus minus plus 2 by 2, 2 get cancelled, 1 by pi. This is the quotient a naught in the Fourier series. So the answer is 1 by pi. For this general formula of Fourier series expansion, this a naught is given by this. Now let us go to the next problem. Now we go to the next problem, 72 problem. It is a question from the linear algebra topic. Consider the following statements regarding properties of eigenvalues. Because of the properties of eigenvalues, eigenvectors, directly we can choose answer. Right? 3 properties are given. We have to choose the correct statement on it. Now check this, correct or not, correct or not, correct or not. Any square matrix A and its transpose have same eigenvalue. This is directly the property. A and A transpose will have same eigenvalues. Both will have the same eigenvalues. So this is the correct statement. The eigenvalues of triangular matrix. Here triangular matrix means that may be upper triangular or lower triangular. For upper triangular, lower triangular matrix, diagonal elements are there, diagonal elements are the eigenvalues on it. For triangular matrix, eigenvalues are its diagonal elements. This is the correct statement. Next, third statement. The sum of the eigenvalues of the matrix, sum of the eigenvalues. Let us suppose nth order matrix, n number of eigenvalues, lambda 1 plus lambda 2 plus and so on plus lambda n. It is sum of the eigenvalues of square matrix A n cross n. A n cross n. According to the property, sum of the eigenvalues of a square matrix equal to trace of the matrix. But trace is the sum of the diagonal elements. A11 plus A22 plus and so on plus ANN. It is one of the property. For any square matrix, sum of the eigenvalues is always equal to sum of its diagonal elements. But here what is given? Sum of the eigenvalues of a matrix is equal to product of elements, product of the elements of the principal diagonal. But here it is the property. The sum of the eigenvalues is not same as the product of diagonal elements, product only sum of the diagonal elements. This statement is correct, but this is not given here. Therefore, that is why this statement is wrong. So this is not same as this. That is why this is a wrong statement. And we are asked to choose a true statement. So this statement is correct, this statement is correct, this is wrong statement. Finally, 1 and 2 are correct. 1 and 2 only means that is given in option A. The first option is correct. Let R be the rank for the quotient matrix of A, the system homogeneous linear equations. A is the quotient matrix of the homogeneous system, and for this quotient matrix rank is already given, having m number of equations, n number of columns, that is variable sum. For homogeneous system Ax equal to O, for a coefficient matrix A m cross n, rank is already given as R. This is the given information. For the homogeneous system, two types of solutions. First of all, solution always exists, and two types of solutions. One is zero solution, other one is non-zero solution. This is always possible, but this may or may not exist. If exists, we try to find a non-zero solution or non-trivial solution. But here the solution is unique. Non-zero solutions are infinite. Many solutions, infinitely many non-zero solutions exist. It is a data. Now check one by one statement. R less than n. Rank of A m cross n equal to R, but R is given that less than number of variables. Whenever rank of A is less than number of variables, the system will have infinitely many solutions. But out of all the solutions, some solutions are independent. The number of independent solutions is given by n minus R. For this, the many solutions exist. Out of many solutions, this number of solutions are independent solutions. Here also given that number of independent solutions as n minus R. So this statement is correct. If m less than n, that is number of equations is less than number of variables, the number of solutions is finite. He is saying that whenever number of equations is less than number of variables, he is saying that finite solution. We check whether it is correct or not. The first statement is correct. Next, second statement. To check the statement is correct or not, let us consider the example. So let us consider x plus 2y equal to 0. Here, how many equations? One equation. M equal to 1. How many number of variables? 2. M less than n. Now we have taken some example here. We have taken, this system is containing only one equation. Number of equations is 1. Number of variables is 2. M less than n. For this homogeneous system, how many number of solutions exist? Infinitely many solutions exist. Many solutions exist. Many non-zero solutions exist. Y equal to 1. If it gives something to y, we get something for x. Or if it gives something to x, we get something for y. We can, like that, we can take many values for one of the variable. Depending on that, we can get other variable values. So we can get the many solutions. So with this condition, we are getting the many solutions. But he is saying that finite. So this is wrong statement. If m equal to n, that is number of equations is same as number of variables, he is saying that non-trivial, that is many solutions exist. We check whether this is correct or not. For third statement, to check the statement is correct or not, let us consider two examples. Example number 1. System is x plus 2y equal to 0. 2x plus 4y equal to 0. It is one system of two equations in two variables, m equal to n. M equal to n case. Okay. But here, even though these two are two equations, both are proportional. Because of proportional, we can get infinitely many solutions. For this, we get the infinitely many solutions. Next, example number 2. X plus 2y equal to 1 equation. Next, 2x minus y equal to 0, other equation. So again, collection of two equations in two variables, m equal to n. For m equal to n, we have taken two examples, example number 1, example number 2. But here, if you write the quotient matrix 1, 2, 2 minus 1, determinant is not equal to 0, only unique solution exists here. For this, only unique solution, 0 solution exists. Now we have taken m equal to n, many solutions, here only 0 solution, 1 solution, unique solution. So whenever m equal to n for a homogeneous system, the system may have either 0 solution, unique solution, or many solutions only. But he is saying that only non-zero solution, many solutions only. But here we have shown that not only non-zero solution, zero solution also possible only. So the statement is wrong. This statement is wrong. The statement is wrong. Only the first statement is correct. So C is the correct answer. Only first statement is correct, because we are asked to choose. Sorry. We are asked to choose a not correct. Not correct means this is wrong. This is 2 and 3 are wrong statement. Therefore, this is the correct answer. D is the correct answer. If you want to choose a correct statement, then 1 is the correct. But we are asked to choose a wrong statement, not correct statement. That is why D is the correct answer. Okay. Right. With this, all the questions from the mathematics part are completed.
In control systems, they ask 12 questions. All are very easy. So, first one, consider the following statement according to second order underdamped system. Peak time, you know the formula, peak time is pi by omega d. Omega d is a what? Imaginary part of the pole. It is a imaginary part. So, that means peak time is inversely proportional, it is correct. And this is not overload, it is overshoot. Overshoot is what depends on MP, depends on what? Zeta. So, second one is correct. Settling time, TS, inversely proportional. Inversely proportional of real part of pole. So, third one is wrong. So, 1 and 2 is correct. Next, for the closed loop transfer given. So, number of poles left, right, and they are asking. Use the RH criteria. S power 4, S cube, S square, S power 1, S power 0. So, here 1, next alternate 11, next alternate 200. So, next year 6, here also 6. So, we can make it as 1 for easy calculations. Here it is 200. Then 11 minus 1 means here you will get 10. 1 0 we can make it cancel. 1 minus 20 means minus 19, 1. So, 2 sign changes means 2 poles system is unstable since it has 2 poles right and 2 poles left. Answer B. Next, consider the following statement regarding the stability of LTI system. A system is marginally stable, inverse response neither goes to infinity nor to 0. So, answer A correct. So, next, a system is unstable, natural response approach to infinity but not at 0, infinity. So, that means second one is wrong. A system is unstable for bounded input yields. So, this is correct. So, 1 and which of the statements are not correct they are asking. So, 2 is not correct. Next. So, here they given they are asking the error constants Kp, KV and KA they are asking. It is type 0 system. Type 0 system gives the constant steady state error only step. For step constant should be there, remainder should be 0. That means answer D. Or you can find KP value, numerator constant. So 1000 into 8 divided by 7 into 9. You solve it, you will get 127. So answer D. Next, so consider the following statement regarding the properties of transfer function. So unit here, unit is essential. No, it is wrong. Unit, some systems may exist or may not exist the unit. So it is not essential. Transfer function, this is a LTI system. It is correct. It is 100% correct. Whose parameters does not change with time. Maybe slight changes due to temperature variation. So the second one is correct. Transfer function independent of input. It is wrong. So which of the statements is correct? Only 2 is correct. Only 2 is correct. D. Next, consider the following statement. Gives the order steps. We know it. We discussed already. This is the first priority. So combination series. Next parallel, second priority. Next loops, third priority. This is fourth. So 1, 3, 2, 4 and answer B. Next. So consider the following regarding the block diagrams through signal flow graph. See, signal at a node, at any node entering the signal is algebraic sum of the what? All the incoming branches, incoming transmittance, path gains. So that means first one is correct. Transmittance is simply related to the transfer function. It is also correct. But transmittance is connected. Now, transmittance means even ratio of two nodes also called the transmittance. So not always between input output. So third one is wrong. So that means statement 1 and 2 is correct. Next, consider the following statement regarding Nyquist stability. Nyquist stability is not geometric. So wrong. So it is graphical method but not geometric. So it is uses the open, correct na? Open loop transfer function only we will use to get closed loop stability in the Nyquist. Instead of solving characteristic equation, Nyquist just we use the open loop frequency response and we will get the closed loop stability. So correct. That means 2 and 3 is correct. Answer D. Next, a DC gain, simply substitute S0 in the transfer function. Check the stability, the stable system. So simply substitute S0 means 2 divided by 1 into 3 into 4. So that means 1 by 6. Answer A. Next, so here simply delta of t, impulse response gives the transient response. Step gives the transient response as well as steady state error 2. So if you select P is 2, Q is 3, that means simply B. Why? Because sign is a steady state, but the no option matches here. This for this S is 1. So that means S1 means option B. Next, so here see numerators are same for all the 4 options. So just you have to check the denominator. You have to check the denominator. That means that is enough. So for that you write the first Si minus A, and find the det equal to 0, you will get it. So if you write Si minus A, simply add S diagonally and take the opposite sign of coefficients. S minus 1, 0, here S, here it is minus 1, then it is plus 1, plus 2 and S plus 3. See here, just find the det. You find the det, you will get the answer because numerator is same. No need to find the what transfer function. So det equal to, so take a here cofactor. So S, then what you are getting S into S plus 3 plus 2. Again here 0, no need to write. Then here plus 1, you take this. Then we are getting what? 1 plus here S. So if you simplify this, what you are getting? So S into S square plus 3S plus 2 plus S plus 1. So that means what you are getting? S cube plus 3S square plus here 2S, 3S plus 1. So which option matches? B. S cube plus 3S plus 3. Numerator is same, so no need to verify. So next. So regarding to the first order system, as you know, say time constant means 63%, not decay, it is rising. So but rising is still 37, that means it is wrong. Rise time, so for first order 10% to 90%, it is correct. Settling time generally 2 to 5%, any value can consider. So, it is what? Settling time is also correct. 2 and 3. So, which of the statements is not correct? That means one is, which of the following above statements is or not correct? That means one is not correct. So, next, that's all. Thank you. Okay, let us look at questions from basic electronics engineering. Go through the question. Consider the following statements regarding applications of PN diode. It is used as a switch in DC supply. It is used as rectifier in voltage stabilizing circuit. Voltage stabilizing circuit, we generally use Zener. It is used as signal diodes in communication. So, 1 and 3 is the right answer. Consider the following statements regarding transistors. They can be made to oscillate with very small power consumption. They cannot sustain mechanical shocks. This is wrong. Their application is limited to few megacycles. So, 1 and 3 is the right answer, option D. The field effect transistor operates with a drain current of 100 milliampere and a gate source bias of -1 volt. The device has a dynamic forward conductance of 0.25. If the bias voltage decreases to 1.2, what is the new drain current? So, the transconductance of the device GM is given as change in ID by change in VGS. So, let us substitute 0.25. The change in ID, you can say ID1 minus ID2. Suppose it is say 100 milli minus X. The change in VGS is around 0.2, 1 and 1.2, so it is 0.2. So, if you substitute the value of X, which is the new drain current, is going to be around 50 milliampere. So, 50 milli, option A is the right answer. Match the following lists regarding bipolar junction transistor. So, here BC147, BC547, these are general purpose devices. So, BC108 is a general purpose small signal amplifier. So, P is 2. So, let us see, P2 is only option D is there. So, we can check the other options also. BF, F means RF power amplifier, Q4. So, there is no need to check the other two. Option D is the right answer. Consider the following statements regarding PNP transistor. The base collector junction is reverse biased to holes. This is a PNP. PNP, the base is generally electron. So, the base region is very thin and it is only lightly doped with electrons. A larger portion of electrons in the base region cross the base collector junction into the collector transistor, creating a collector current. So, 2 and 3 is the right answer, option B. For a JFET, the typical values of amplification factor and the transconductance are given. What is the dynamic resistance? It is a simple substitution problem. Mu is GM into RDS. So, just to substitute here, mu is given as how much is mu amplification factor is 80, GM is 200 micro and RDS is 80 by 2, 8 by 2, 8 by 2 is 4, so 400 kilo ohms. There is no need of driver stage if FET is used as a power amplifier instead of BJT. So, at the last stage, driver stage, we need high input impedance. So, let us see the options, digital circuit, no risk, power gain of FET. FET is used as a voltage control device. What do you mean by voltage control device? It has high input impedance. So, the option D. Match the following regarding the field effect transistor. Common source, common drain and common gate are given. Impedance matching, general purpose or something is given. So, let us pick some option here. Common drain, generally it is used for impedance matching. So, Q should be 1. So, let us first check if there is any Q1. There is only one option. No need to check the other two options. Okay. Match the following regarding the bipolar junction transistor. The same question again it is given for BJT. So, common collector is for impedance matching. Q2. Let us see if there is any Q2. Yeah, there is only one option. No need to check other options. Consider the following statement regarding frequency response of BJT amplifier. The C amplifier has high gain and relatively narrow bandwidth. This is true. CC amplifier has low gain and larger bandwidth, and CB amplifier has high gain and larger bandwidth. So, the gain of CB and CC it's less, C is more. So, 1 and 2, option D is the right answer. In a common collector amplifier, the impedance between base and emitter is magnified because of emitter resistors are generally called degenerative resistors. Degeneration means negative feedback. In Colpitt's oscillator, the feedback is controlled by capacitances. Consider the characteristics regarding ideal operational amplifier. Operational amplifier has infinite slew rate. So, here it is given 0. Op-amp must have extremely high inherent voltage gain. This is true. And infinite output impedance. This is wrong. So, only 2 is there. Option C is the right answer. An inverting amplifier using a 741C must have a flat. See, 741C operational amplifier. I think they have a flat response up to 40 kilo. That means their slew rate. If you see the data sheet, it is around 0.5 volts per microsecond. Micro means 10 power 6. So, this is given as 2 pi F max V max. So, now your V max you can get by substituting F equal to how much 40k. So, you will get V max. But what does he want? The gain of the amplifier is given. So, when gain is given, what is the maximum peak to peak of input signal? We know gain is output by input, is it not? That means input is output by gain. Input is output by gain. So, first take Vm, substitute here, but mind you, he has asked peak to peak, not peak. So, peak to peak means you have to multiply this by 2. Suppose this value x, 2x, okay. So, 137, if you substitute, you will get this answer. The value of capacitance used in a capacitor filter connected to a full wave rectifier of standard aircraft power supply 400 hertz ripple factor. This is again a standard formula. The ripple factor R is given by 1 by 4 root 3 FCRL. So, just substitute the values, you will get RL value 10%, 10 by 100, which is 0.1, 1 by 4 root 3, frequency is 400, resistance is given 500. So, that means the unknown is C. So just substitute the value of C, I got 72.18 something. So 72.2. Option A is the right answer. Match the following lists regarding RC filter. So we know low pass filter will have a transfer function k by 1 plus s tau, k by 1 plus s tau if you take the magnitude. So 1 is 4. High pass filter is ks by 1 plus s tau. So which is options. RC is an integrator. The term integrator means integration. The term differentiator means differentiation. So you can see 141. What are the options? C. Okay, so that's all from analog circuits. There are around 19 questions. Okay.
Yes, good evening everyone. So hope everyone did well according to your level best. Now let's see, from total machines we have around 12 questions here. So this time little less questions overall. Now let's see the first question here. A transformer core is wound with a coil carrying an alternating current at a frequency of 50 Hz. Okay. The hysteresis loop area of 70,000 units. Hysteresis loop area when the axes are drawn in units of 10 power minus 4 Weber per meter square and 10 square ampere per meter. Okay, B and H units given. What is the hysteresis loss? By assuming magnetization to be uniform throughout the core, volume of 0.02 meter cube. So here simply first thing you should know how to find hysteresis loss from hysteresis loop. So BH loop or hysteresis loop area will give always hysteresis loss for one cycle. Okay, hysteresis loop area is nothing but hysteresis loss for one cycle per unit volume it is. Now if you want total hysteresis loss, you should multiply with supply frequency and also whatever the volume is given here. Okay, now directly if you find the total hysteresis loss, no, the total hysteresis loss at a time I am writing here, which is area of hysteresis loop multiplied with supply frequency and also total volume of that core. Now what is the area of hysteresis loop? 70,000 units given and their units also given, means x axis, y axis units. So substitute completely 70,000 into 10 power minus 4 Weber per meter square B and H is 10 square. So this is hysteresis loop area it is, okay, into total supply frequency is 50 Hertz, this is 50 and total volume of core is given as 0.02. Now this is 50 actually, substitute here. If you calculate, you will get totally it is 700 watts. So the answer for this option B only. Next, see this. See this question. The total iron loss in armature of a DC machine running at 875 RPM. See, in DC machine, iron loss means majorly takes place in the rotor, that is armature core, and also under pole shoes. But major loss means in the armature, that is only they given as 1100 watts. What is the approximate braking torque due to iron loss? Braking torque. So any torque relation is what? Power developed by omega. So here we need braking torque which is corresponding to iron loss. So what is the iron loss power? 1100, no? So power divided by omega. What is the power loss? Power loss is 1100, and what is the omega? 2 pi n by 60. So at what speed it is? 875. So 2 pi n 875 divided by 60 it is. Now if you calculate, you will get 12 Newton meters. So this is the braking torque which is due to power loss. Next question, let's see. This is the question. A 0.5 HP 6-pole induction motor is excited by a 3-phase 60 Hz source. 60 Hz here, take care. 6-pole 60 Hz. If the full load speed is 1140 RPM, then what is the percentage slip of motor? So slip formula is what? Ns minus N by Ns. So what is the Ns here? For 6-pole, if it is 50 Hz, it is 1000 RPM. But for 60 Hz, no, Ns synchronous speed is 1200 RPM here. Ns minus N, what speed it is rotating? 1140 divided by Ns 1200. If you find out, this is 60, no, means 5% of 1200 it is 5% we get. So slip is 5%. Option C is the answer. Next. A 50 Hz induction motor wound for pole amplitude modulation. Pole amplitude means pole changing technique is there, no, in speed control method. Maybe poles increases or poles we can decrease. How much modulation is given here? It has 20 poles initially, and the modulating function has 8 poles. Means the poles may be increased by 8 plus 8 or decreased by 8. Now at what 2 speeds will the motor will run? So initially 20 poles are there. For a 20 pole condition, what is the synchronous speed? When poles are 20, the synchronous speed will be Ns equal to 120 F by P, will get 300 RPM it is. So induction motor will rotate always near to that, 280, 290 like that. Now pole modulation if you applied, means if you take addition of that modulating poles whatever is given 8, then we get 28 poles. And if you take subtraction, we get 12 poles. So if you take pole modulation, so new poles may be 20 minus 8, 12, or 20 plus 8, 28. Any one possibility, either increases or decreases. Now if you take 12 poles, for this synchronous speed corresponding 120 F by P, you will get 500 RPM it is. And for 28 poles, we will get the speed around 214.2 something RPM. Now from the given options, if you see, no, the possibility is 300 and near to this 214.2 RPM. So this is not given in the options 500. That's why these two are the possibilities. So which option is correct here? Option A it is. Next. A 3-phase synchronous generator produces open circuit voltage of 6928 volts. This is line voltage given. And for a DC exciting current or field current of 50 amperes it is, for a field current of 50 amperes. And also the short circuit current in 3 line currents given, means the line currents in 3-phase system is 800 amperes short circuit current, ISC equal to 800. But it is not given for which current it is. Generally we have to consider either open circuit, what is the question actually? Synchronous reactance per phase. Synchronous impedance per phase or reactance per phase, always we calculate in per phase for the same field current it is. Open circuit voltage by short circuit current. So this is also for same. Then synchronous reactance, open circuit voltage per phase divided by short circuit current per phase for the same value of field current. So let us assume this is same value only. Now here delta star not given. So when it is not given, generally alternators will be in star connection always. Now let us take star. So as it is, line phase will be 6928 by root 3 divided by, this is line current phase current same in star, which is 800. Now simplify 4.99 means around approximately 5 ohms we get. So the option is D. D is the correct one. Next question. A transformer on no load. A transformer on no load has core loss 50 watts. No load condition, core loss 50, and it draws a current of 2 amperes and has induced EMF of 230. Generally induced EMF given, supply not given. So almost under no load condition drop will be very less. So supply voltage, EMF almost same, but little bit supply voltage actually more than 230. So what is the power loss always? Power taken by transformer under no load condition is V naught IW only. IW is what? I naught cos phi naught. So they are asking here what is the core loss current? Core loss means IW, and what is the power here? 50, and voltage is take almost same 230 into IW. So if you simplify, you will get IW 0.217. Actually this voltage is little bit, maybe 232 to 33 like that. Then if you take little bit more, no, then exactly 0.216 also we get. So option A is correct for this. Next, this is on efficiency of transformer. See, a 500 kVA transformer has efficiency of 95% at full load and also at 60% full load. Same efficiency 95% at full load and also at 60% full load, both at unity power factor. So they are asking to find out the losses of the transformer. Separate out the losses of transformer, means iron loss, copper loss we have to calculate here. How to simplify? So we know the formula, no? What is the efficiency at any fraction of load? X volt ampere cos phi divided by X volt ampere cos phi plus iron loss plus X square full load copper loss. So if you substitute in that, initially 0.95 efficiency at which condition? Full load means X is 1 into 500 into 10 cube, at which power factor this is 1 divided by this is same 5 into 10 power 5 plus iron loss plus 1 into copper loss. So cross multiply one equation we get iron plus copper. Simplify this, some value we get, let equation 1 it is. Same efficiency at 60% full load also, means X value 0.6 here, 500 into 10 cube, this is also at unity power factor 1 divided by 0.6 5 into 10 power 5 plus iron loss plus X square means 0.6 square into copper loss. Then simplify this one also, iron plus 0.6 square copper loss, full load copper loss it is, some value we get. These are the two equations, you need to simplify Ax plus By equal to C. Let equation 1 minus equation 2 directly. So iron loss gets cancelled, simplify, we get iron loss is this 9.8 kilowatt and full load copper loss will get 16.4 kilowatt. So option D is the correct one in this. Option D it is. Okay. Next, consider the following statements regarding three-phase transformer connections. Here given delta-delta connection is economical for small HV transformers. So delta-delta is economical for small HV transformers. Is right or wrong? Yes. See, this delta-delta we use for small ratings only. So even for high, when it is high voltage, no, generally star is best. But for small HV ratings, delta-delta also we can utilize. Okay, because delta-delta having one advantage. Even one phase damage, we can operate it as open delta. So it is a continuous supply, something is possible here. And star-star transformer suits large LV transformer. Star-star we can go for HV, because for high voltage star is the best one. So this is not correct one. And star delta is most commonly used connection for power system. Wrong. Because in power system, mostly distribution side, if you take, mostly all transformers are delta star, not star delta. So here they are asking which of the above are correct. So only one is correct. See, next. See this. A 240 by 120 volt 12 kVA transformer has full load efficiency of 96.2%. It is connected as auto transformer to feed a load at 360 volt. Okay, auto transformer it is converted from 2 winding. What is the kVA rating of auto transformer? So anyhow, no need to take that efficiency here, no need. So directly, if 2 winding transformer rating is this, then what will be auto transformer rating? So we have to take 240 divided by, connect these two in series additive connection, then we get 360. So secondary 360 load connection. Okay, this is the auto transformer rating we have to connect like this. Then use the formula for kVA rating of auto transformer is equal to 1 by 1 minus k, means 24 divided by 36 into 2 winding transformer capacity 12 kVA it is. Now simplify this, you will get 36 kVA rating. Okay, 36 auto transformer capacity. Next, for a 6-pole DC machine with 16 slots having 2 coil sides per slot, 2 coil sides nothing but double layer winding it is, and what is the commutator pitch for the wave winding they are asking. So there is one formula for commutator pitch, which is C plus or minus 1 divided by pair of poles P by 2. Okay. Now for lap winding it is directly plus or minus 1 we take for simplex connection, and for duplex we take plus or minus 2, and for wave winding this is, first of all, C is coils here. How many coils will be there for double layer? Number of coils for double layer is number of slots, which is 16. Now if you substitute here, 16 plus 1 divided by 6 by 2 is 3. So it will come 17 by 3, and one more combination 16 minus 1 divided by 3, which is 15 by 3 coming. 15 by 3 is what? 5. So it should be an integer. Number of commutator segments, no? Commutator pitch is nothing but distance between two segments in which the ends of one coil are connected. This is always integer only. So we never get fraction 17 by 3 like this. So it is coming 5 here. So 5 segments is correct. Next, this one, see the question. Consider the following statements regarding speed control of DC motor. So they given first statement, in field control method, speeds higher than rated speed cannot be obtained. Actual field control will give higher speeds only, but they given cannot be obtained. So this is wrong. Now for motors requiring a wide range of speed control, field control methods leads to unstable operating condition or poor commutation. Yes, this is one drawback of field control method. So in the field control, when we reduce the field current, when field current is reduced, flux reduce, speed increase. But during that, as flux is reducing or weakening effect is there, flux is getting weak, spark will be increased, means commutation will be very poor. So here this is correct only. The field control method is not suited to applications needing speed reversal. If you want to reverse the speed, no, the flux should be reversed. So it is not suitable. That is, both direction control is possible for which method it is? It is odd linear speed control method, but not here. It is not suited. So which of the above are correct? So 2, 3 correct here, means option A. So these are the questions from total machines we have. So no need to worry whatever you written and whatever you lost today. So all the best for the upcoming GATE exam. So this is our total today's session.